All right, so for the homework, then we're going to look at 3 or 4 problems from the side or the sheet that has doesn't have the Roman numerals on it. Okay, so it's the side that's starting with sodium chromate, and that's the one I'm going to show you. Or one of the 4 I'm going to show you, sodium chromate. Okay. So what the sheet does, the homework sheet gives you, is the words sodium and chromate, and you're supposed to write a formula for this. Alright? So, if we look at this, we can see an ATE ending here. And as I pointed out to you yesterday, the ATE ending is reserved almost exclusively for polyatomic ions. Okay? So I can go to the list of polyatomic ions on the common ions list and find this polyatomic ion. And it is CrO4, 2 negative. Okay? So I need to find this part of it. Now we've been working with elements enough now that you hopefully are recognizing some of these elements. And if not, you just got to search around for it. These things are going to be either on the periodic table or they're going to be on the common ions list. And if you just have to dig around till you find it, you just have to dig around till you find it. But this one is sodium, is Na. We need to know what charge of sodium has, so we'll turn then to the periodic table on which I've listed oxidation numbers, 1 plus. So the sodium then has a 1 plus charge. What I need is a formula that has a balance of charges. So since I have a 1 plus charge on this sodium, and I have a 2 negative charge on this chromate, I want to have a 0 charge when I'm done, and the way that I make this work out is to use coefficients to multiply either the 2 negative charge or the 1 plus charge to get everything balanced out, or sometimes both. And what will work to make that happen is the 2 here and a 1 here. The simplest whole numbers that will get me there are these 2 coefficients. If I need 2 1 plus charges to balance out a 1 or 1 2 negative charge, then I also need 2 sodium ions to balance the charge on the chromate. And when I put it together then, I'll have a sodium, but I'm only, this 2 coefficient tells me I have 2 of these particles. When I bond these 2 particles together with this chromate ion, to show that they're bonded together, we use a different notation system. This coefficient becomes a subscript to show that it's bonded together and with the chromate. And so the formula for sodium chromate is this. So that is the correct answer to number 1. Alright, then I'm going to go to number 3. I'm going to skip one here. I'm going to go to magnesium nitrate now in number 3. Okay, so we have an ATE ending again. All the ATE and ITE endings all signal to you have a polyatomic ion. There are only a handful of polyatomic ions that don't have ATE or ITE endings. Okay, 2 of those you should already know because we've used them before in Unit 3. That was the hydroxide and the ammonium. Okay, those don't have ATE endings, but you should know what they are because we used them a good bit. In fact, they're on the last test, or one of them. Let me see, wait a minute. One of them was on the last test. But we went over ammonium twice. So hopefully you remember what that is. Anyway, so nitrate, you look it up on that common ions list. The list of polyatomic ions, and specifically the anions. And let's see. Nitrate's right here. Okay, so its formula is NO3. Has a 1 negative charge. You've got to be careful about these. Some students confuse the fact that a 3 down here and a negative charge up here mean 2 different things. And they'll assume that nitrate has a 3 negative charge. That's not the case. The 3 in the lower right means there are 3 of these atoms. The negative charge up here, the charges belong in the upper right. So there's a separation between these 2 ideas. Okay? Just like when we're doing nuclear notation. Okay? The atomic mass went here and the atomic number went down here. So each of the four corners means something different. All right? Charges go in the upper right, number of atoms in a formula go in the lower right. Now back to what we're doing here. We've got a nitrate ion, we have a magnesium ion. Magnesium is an element. You can look it up and dig around on the periodic table till you find it. And then once you find what that symbol is, and it is Mg, you look up the charge. And the charge on the magnesium is 2 plus. Actually, you might have noticed that everything in column 2 is 2 plus. Everything in column 1 is 1 plus. Well, hydrogen has a 1 negative sometimes, but everything in column 1 has a 1 negative. Almost everything in 3A over here has a 3 plus charge. All the negative charges in this column right here are 1 negative. All the negative charges in this column are the oxygen family, 2 negative. So there's a pattern there. You might not even need to look them up. Alright, so what I'm going to need is the correct number of magnesium ions and nitrate ions to give me a neutral charge when I'm done. Okay? Now this is going to neutralize the charges. So the answer has no charges written on it. Okay? The compound won't have any charges written on it. Alright, so how many magnesiums and nitrates do I need? 2 nitrates are needed to balance out or neutralize this 2 plus charge. Okay? Now to show 2 nitrates then, I can't just put a 2 here. That looks like 32 oxygens. That is not what I want to show. In order to show that there are 2 nitrates, I put a parenthesis around the nitrate to indicate that. Does that make sense? Okay. Well, so let's jump down now to the section where you're writing the names from the formulas. I'm going to go to number 11 on your homework sheet. And we got KCH3CO2. Okay? So the way that I teach you to approach this is you look at the formula and you see that there are more than 2 elements. If there are more than 2 elements, one of the first things you want to do is to look and see if there's a polyatomic ion in there. Now you may not recognize polyatomic ions readily, but you can compare. Okay, you've been doing compare and contrast since what? First grade? Second grade? Third grade? Somewhere in there? You can go to the restroom if you need to, yes. Okay, are you grading somebody's paper?
Yeah, but
Alright. So if you look carefully, this part of this formula matches this ion right here, acetate. Okay? So we know the end of this word is, or this formula is called acetate. There's our polyatomic ion. It takes care of all of that. All that's left is to name this, the K. And that's potassium. You look it up on the periodic table, it's potassium. And that's it. Okay? Alright, let's go to number 15 then. And do this, 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 and this. Okay? Now in this case, you've gotten a little bit of extra help because parentheses are only used when you have more than one polyatomic ion. That's the only time when you're writing formulas that you use parentheses. Maybe I should say the only time we'll use in this class. Okay? So that means everything inside the parenthesis is one polyatomic ion. It's all part of the same polyatomic ion. So just look on the common ions list and find HCO3 and you'll find hydrogen carbonate. Okay, now I actually prefer bicarbonate. And so I would accept either one of those. Alright, so it can be called hydrogen carbonate or bicarbonate. Alright? Then we just got to look up the first thing, and it's called strontium. Okay, so either one of these is acceptable. Make sense? Alright, then I want to flip over on the back of your worksheet and do 1 on the back, because that's the side that has the Roman numerals. The only one what I want to do is one of those where we have a formula, we're trying to find a name. So I'm going to go to number 10 on the back side. Okay? And you were given this, and you have to figure out the name. Alright, I've got more than 2 elements. I probably have a polyatomic ion. What? Oh, is it a 3? I'm sorry, thank you, 3. Alright? I've got more than 2 elements. It's probably a polyatomic ion. So I'm going to look on the list of polyatomic ions, common ions, and find SO3, 2 negative. That's a sulfite. Okay? Then I'm going to look at this, the lead part of it. Okay? When I look at the periodic table with the oxidation numbers, I'll see that lead has more than one potential oxidation number. It can be either 4 plus or 2 plus. So I have to figure out which one is this. So what was the charge on that sulfite? And the whole thing has to come out to be PbSO3. I've got to have a 0 charge over here. This is a 2 negative. I've got 1 2 negative. So Pb, I'm sorry, I didn't know what charge I have when I have only 1 Pb. It'll make all this work out.
But is it kind of almost the
Exact
exact same thing?
same thing.
As the other two.
Close, but we got to name lead with a Roman numeral because it has more than one potential oxidation number. Yes. Has to be a 2 plus. Okay? Make sense? Okay, so 1 times 2 plus is 2 plus, 1 times 2 negative is 2 negative, and a 2 plus a 2 negative is a 0. That's what we want. So that means that this lead has to be a 2 plus version. Okay? Version 2.0. Alright? The name of this ion, since lead has more than one oxidation number, we have to show which one of these 2 leads it is. It's not lead 4, it's lead 2 plus. And we call it lead Roman numeral 2 in parentheses with no spaces. Does that make sense? Alright, let's talk about how you're going to grade this, since you're helping to grade the papers. Okay. For formulas like this, you're going to give each symbol a point. So the sodium gets a point, the chromate gets a point. We're only going to give it 1 point because you looked it up. It's just write down CrO4 the way it looks on the common ions list. But we also have to give this 2 a point. Okay? So sodium chromate would be worth a total of 3 points altogether. Does that make sense? Alright. Magnesium nitrate. Magnesium's worth a point. Nitrate's worth a point. The subscript 2 is worth a point. Whoops, 1 point. And the parentheses is worth a point. Both front and back parentheses are worth a point. Does that make sense? So this would be worth a total of 4 points. Potassium acetate. You only looked up acetate. There was no change in any words or anything like that. So acetate's worth 1 point. Potassium's worth 1 point. So this answer altogether is worth 2 points. Okay? The hydrogen carbonate or bicarbonate are both acceptable. That's worth a point, and the strontium's worth a point. So this question is worth 2 points. Okay? The reason I did one from the back side is because we added something extra here. You looked up sulfite, so that's worth a point. You looked up lead, that's worth a point. But you had to figure out that Roman numeral, so that's also worth a point. So this problem here is worth 3 points. Does everybody understand how we're going to grade this? Okay. Now, let's see. Just to be clear, the side of the worksheet that has 20 problems on it, Okay, that's worth a total of 51 points, if you want to know what that is. The worksheet that has 20 problems. When I added it up, I got 51 points. The worksheet that had only 16 problems on it, I added it up to be 49 points. Okay, so the total or maximum is 51 on the 20 problem sheet and 49 on the 16 problem sheet.